I'm a senior HPC technical specialist in Europe, and I focus mostly on CPUs for HPC and AI, although I touch at the system level. I will be talking today about mostly what we announced last night, European time, the new generation, the second generation of Intel Xeon processors. So that's the first part, the HPC platform with the CPU. And that new processor family supports a new type of memory technology, non-volatile memory DIMMs, that are bringing a new hierarchy. As we heard many times during these past 2-3 days, there was a lot talked about moving data. And it's true that when we get to exascale, a lot of the energy is spent in moving data. Processing is not for free, but processing may not be the majority of where the energy is spent. And if you can get the data closer to where you need to process it, or if it can be processed somewhere else, as was presented in some of the accelerators that Thorsten talked about for the networking, then that's helping a lot. So I will be talking about that. Data is really getting more and more prominent because it's now getting available. However, it's not that much processed. As you can see, only 2% of the data that is produced is actually used. And the problem is that there is a lot of information in the data. There is a lot of value in the data. And when the term value is used, then clearly there's business behind it, there's dollars. And we have seen it starting with big data, Hadoop, and then getting to HPC and AI, where we want to get insights. So the idea is, as there is a lot of data, let's get something out of it. So we need to move it, we need to store it, we need to process it, and I'm going to talk about that. As I said, value is in the data because there is insights. And we need to be able to extract the insights. It's feasible already. We have a lot of good solutions. But there needs to be a little bit more provided in the coming solutions, where we also need to take into account the security of the data, the security of the processing of the data. Everybody remembers last year, January, when the Spectrum meltdown was announced, I would say, or was hitting us. And security is the job of absolutely everyone. Intel do their part of it, and in the new processor, we are implementing hardware mitigation, but there still needs some mitigation to be done in hardware and software, like in the OS, in the firmware, in the VMMs. And there needs to be best practices by the users or the IT administrators, and all of these together will help. But we are providing the basic bricks into the hardware. All of this to provide value, good customer orientation, and what we are bringing with this new generation of processors is processor for general data center type of workloads, but also processors optimized for specific workloads like search or NFV type of applications or single socket solutions. So there are more and more availability of targeted solutions. As usual, when we bring a processor to the market, it means that we have done all of the ecosystem enabling work that guarantees that the applications will benefit from the new features that the processor is bringing. So that's our ecosystem enabling that we start several years before we launch the processor. And on this one, I'll talk a little bit about the AI part, and you will see that we've done a lot of good job to make sure that you can get as much performance and easily accessible as you can from the solution that you will get from your preferred OEMs. All of this, of course, to give you access to higher levels of performance or better TCO or any solution and metric that you want to implement. The Intel portfolio for the data center is extremely large. As we presented in December, our 3 pillars are to move, store, and process the data. And we have a lot of solutions to move the data: Ethernet, Silicon Photonics, OmniPath, architecture, fabric. Storage with the latest SSDs with 3-NAND technology, but with quad-level cells, where each bit embeds actually 4 bits, and you choose, or the system chooses the voltage to see the value, which means double the density from the TLC, the 3-level that we had before. The Optane DC solid-state drive, and we are bringing, or we brought yesterday, a new dual-port solution, the D4800X, which goes up to 1.5 terabytes, and the Optane DC persistent memory that I'll talk a lot about, because that's coming specifically with the new 2nd generation of Intel Scalable processor, the Cascade Lake that you know of. But we also have a lot of other hardware solutions with the XEON, the Atom-based processors for servers, the FPGAs, the Nirvana neural network processors, and Movidius. All of this coming with heightened security, with software optimized solutions, including some ready-to-go solutions through select solutions that I'll talk about in a moment, because a lot of people don't know that. What we have announced yesterday is new products on all of these green products. So that's a lot. Now, we are not here to talk about all of them, so I'll talk only about those that I think that for HPC really make a lot of sense. So the new Cascade Lake processor, the Optane DC persistent memory, the non-volatile memory DIMMs, some optimization in software and how they play a role in the fully available and validated select solutions. As you can see, the 2nd generation is easy to remember because we have increased the processor generation in the numbering from 1 to 2. So if you've been used to the 6148 or the 8280 or 8180, then now you will have the 6248, the 8280. And as I said, we have a lot of options. Like if you want something which is extended temperature for a very specific embedded solution, then there will be a T version, something which is search optimized with an S, something which has some different features like different levels of guaranteed frequency at boot time, depending on the number of cores that you boot with at boot time, then it's a Y extension, etc., etc. There's a whole portfolio. This new generation of Xeon scalable processor starts with the bronze that brings the easy and needed level of performance and features, the bronze 3200. Going up, you have the silver 4200 which brings a little bit more features. The bulk of the solution that we are selling is mostly in the 600 or 6200 generation, the gold generation that supports the highest level of performance in terms of memory bandwidth and ratio to price. The highest performance comes from the 8200, the platinum. And we are just bringing to life a new one, which is the Platinum 9200, which is the highest level of performance in both flops as well as in bandwidth. That's a new class of processors. We call it advanced performance processor. For those who have heard it in terms of code names, that was called Cascade Lake AP for advanced performance. Let's talk a little bit about this new beast. And I'm using the word beast just because I read it in the press this morning. The analysts and the journalists have been extremely pleased with this 9200 processor that comes with up to 112 cores in a two-socket system, which means that if you do the math, it's up to 56 cores in one socket. So we are going a little bit above what we had before, because Skylake was up to 28, now it goes up to 56. Compute density is extremely high, and you can get in a 2U system 4 nodes with each 2 sockets, so that means a lot of cores. In terms of turbo, it can go up for the 56 core up to 3.8 gigahertz, and because you have a large number of memory channels, we have 12 memory channels for each socket, which means that in a dual socket system you have 24 sockets up to 3 terabytes of high frequency 2933. Great, okay, so how does it translate in terms of what is the SKU stack? What types of processors are we bringing? We are bringing to market 3 SKUs, the 32 core, the 48 cores, and the 56 core. Turbo are pretty good, and the cache size is awesome. I'm extremely proud of this one, the 9222, that has 32 cores, but that has the same level 3 cache size as the 48 core. If you do a stream on that one, you get about 6 gigabytes per second per core. And for memory bandwidth bound applications, this rocks. In terms of performance, about 2x the performance of the 8180, and we have measured indeed 2x. In terms of AI inference, with the DL Boost VNNI type of instructions, then we get 30x the performance that you had with the available versions of the topology and the framework at launch of Skylake in July 2017. About half of it is coming from the VNNI, the rest is coming from all of the improvement that we have done on the coding of the framework. And in terms of performance, we are taking the 82 and the 9282 and comparing it with the EPIC 7601, a little bit over 5x the performance on lean pack, if you want a metric. Usually when we talk about comparison, we get 20% higher performance, 30% higher performance, 20% lower cost per flops or something like that. Here we are talking about serious metrics. 5 to 6x the performance is not something that you get every time. But now let's look at the mainstream second generation of Xeon scalable processors. The platinum one, which is one that sells extremely well in HPC because usually people want a lot of cores. We have already been publishing 95 world records in terms of performance. Let me remind you of what happened in 2017. We came up with the Skylake and we published a lot of superb world records in terms of performance. Then came Spectre and Meltdown in January 2018. And we worked on all of the mitigations that were needed so that security would be less compromised. In software, obviously, with the OS vendors, the VM vendors, with through the firmware and the microcode updates that we released that potentially you implemented. And there was a lot of press saying, oh, we are losing a few percentage of performance, but in some cases, we are seeing up to 10, 15, 20+ % of performance for some very IO specific types of workloads. We worked from before January up to August, September. And you know what? The press stopped talking about the performance impact that those mitigations had. Why did they stop talking about it? Just because we worked on it with the ecosystem. Intel really drove it, really opened up the gates of information to make sure that we would have solutions for you, the end users, to implement. And around September, October, we published 90+ new world records on Skylake. No hardware change to Skylake, just software mitigation through the microcode updates in the OSs, in the firmwares. And that's how you can be sure that the levels of performance that we offer, we guarantee, we show it, we prove it, and the mitigations that we have implemented have been extremely successful because they helped some lazy developers, including ISVs, to clean a little bit some of their codes, especially with syscalls that were useless. And that's how it delivered higher levels of performance for you to take advantage of. Here we're doing exactly the same, again, new levels of performance. The Xeon second generation scalable processor will be available in single socket, dual socket, 4 socket, 8 socket and above. There will be some SKUs that will run up to 4.4 gigahertz. Support with the non-volatile memory will go up to 4.5 terabytes per socket, which means up to 36 terabytes in an 8-socket solution. System memory capacity is doubling from the previous generation, and the performance of the memory also increases by 10% because now we are supporting the 2933 megatransfer per second DDR4 DIMMs and higher density with 16 gigabit DIMMs. Across the whole range of the SKU stack of Xeon scalable processors that we are bringing, we are showing some extremely high level of performance. First one here is typically data center servers or HPC systems are refreshed every 4 or 5 years. In terms of data center in VM densities compared to the Ivy Bridge, we have 3.5x the density for VMs. In terms of performance, from the previous generation on the 5100. So not always talking about the top SKU, but something that is more reasonable. 33% average performance improvement for a system that will be at about the same price. So that's pretty interesting. DL Boost, as I said, you remember the 30x that I talked about earlier? 2x is coming from VNNI, 2x is coming from doubling the number of cores, the rest is coming from the improvement that we have made. And here we are seeing from July 2017, 14x multiplied by 2 for the 9200, doubling the number of cores, you're close to 30. So the 14x July 17 to now with the new processor. And that I've already talked about, that's the top SKU of the 8200 family with 3.1x better performance than the AMD EPIC 7601. There are a lot of new features that are implemented in this family of processors. And they range from, as I said, the mitigation of the side channel methods, spectrum meltdown, and we have been publishing regularly some information about which one falls in of these methods fall in which categories, the variant 1, 2, 3, 3A, 4, L1TF, etc. And we are keeping the community updated about this, and we work with the community to find some solutions when there is a new method being published. There's encryption and accelerators available in some of these solutions. There are new security libraries, not necessarily needed for HPC and AI workloads, but they are available. Deep Learning Boost, as I said, the VNNI, the solution for inference that doubles the performance, so divides by 2 the time it takes to do the inference, and I'm not talking about the theoretical peak, it's really what is being measured. Some new technologies for speed select, it's a solution by which you can configure at boot time how many cores you want to use, and there are 3 versions at boot time that you can choose from. Let's say that you have a 24-core processor, but that for a month you want to use 8 cores only, but you want to guarantee a higher base frequency, then you boot with 8 cores and it will guarantee a higher base frequency. We have seen this of interest in FSI. We have seen that of interest in some situations where the end user pays on a per core basis. In that case, what they want is a low core count, high frequency solution, but can they afford to have an heterogeneous solution in their data center? Potentially not. In that case, they can have a generic processor that can boot at, let's say, 2.1 gigahertz 24 core, 2.3 at 16 core, and maybe 2.5 or 2.6 at 8 cores, and that gives a much better TCO. And there are a lot of new infrastructure management technologies that are available with this family of processors, including the new Ethernet 800 series, which is a dual 100 gigabit Ethernet solution. As I said, with the 9200, we have about 30x the performance of what you had with the Skylake processor in July 17. With the 8200, you have 14x. Those small numbers here are just references that you can look at in backup, because each time Intel publishes a certain level of performance, we always publish the full detailed configuration of the machine with all of the OS versions, driver versions, everything, so that you can potentially try to replicate it and make sure that we are not just putting BS marketing anywhere. So on this one, the 30X is for CAFE with the ResNet 50, and that's something that we are working on very heavily. CAFE as well as TensorFlow are the frameworks that we really focus on. Of course, we are not leaving the others on the side, but those are the ones that are the most used, and therefore we are making sure that if you want to run any type of inference or training, then you have the best level of performance if you choose the right versions of the framework online. So I talked about the XEON scalable processors. Now let's talk a little bit about the Optane DC persistent memory. We've seen something similar earlier when Stefan Gillisch from Intel presented his AI pitch on Monday. We know that the closer to the CPU, the better for the data in terms of how much time it takes to get it to the cores for processing. The 3D NAND SSDs on PCI Express are already bringing data closer to the node. We have come up about a year ago with the Optane DC solid-state drive, which has an extremely high read and write level of performance. If the read level of the 3D NAND and the Optane are about the same, 500 kilo IOPS, then the write here is about the same, 500K, while here it's a lot less. So if you have to write a lot on storage, local to the node, then this one, the Optane DC solid-state drive is really great. But we took the same technology, the 3D crosspoint technology that you find in the Optane DC solid-state drive, and we put it on a DIMM. And that's what I'm going to tell you about, because in that case, you have a large space on a DIMM form factor that can be used either as memory or as storage, and you choose at boot time how much of it you want to put as system memory, how much of it you want to put as storage. And I've played with it, and it's really exciting. So that's a memory innovation, which means that we are building on the 3D crosspoint technology that we have come up with on SSDs, and we are making it available on non-volatile DIMMs. Up to 512 gig per DIMM. As you can put one per channel, and only one per channel. I'm sorry, there are 2 DIMMs per channel, but you have to have still DDR4. So that means 6 times half a terabyte, 3 terabytes per socket, 6 terabytes in a dual socket solution. It's affordable. I won't talk about price here, but in terms of gigabyte, dollar per gigabyte, it's aggressive, I would say. And all this brings some new levels of ideas for what people can do with it. I'll talk about some examples that we have been talking about yesterday in the announcement. But each time I talk about it under NDA to customers, they say, wow, I have an idea, I know what I can do with it. And each time it's mind-blowing. Oh yeah, I didn't think of that. But so there's always something interesting to do. It can be used to increase the memory size. It can be used to have more VMs. It can be used to put file systems that are needed extremely close to the CPU. There are plenty of use cases that are coming up with this. In terms of performance and persistence, that's where it makes the big difference, because performance is the bandwidth and the latency, more or less, that you have for DDR. But it's for non-volatile memory. And that means that if you have, for example, a large database that you have to load each time you run your application, then it's already sitting there. You don't need to bring it through some other channels, and that saves a lot of time. Performance per TCO dollars, large capacity system, key workloads, save more, do more, go faster, as usual. We provide some ingredients. The OEMs are building systems from it, and then you, the users, come with brilliant ideas of what you can do with it that nobody thought of before. These levels of performance are measured on a 256 gig module. As you know, there is a 512 gig module also. It can go from 12 watts to 18 watts, and you can choose how much you put power when you boot it at BIOS, boot time in the BIOS. Of course, the higher the power, the higher the performance. But in some cases, you want to use it more for storage, close storage, or storage close to the CPU, and you may not need all of the level of performance. What is of importance to you in that case is the persistence of the data. And in terms of read, so I've used 256 byte because that's very close to what a 4K block performance would be like. The 64 byte version, it's just because it is memory, therefore you can access it at the cache line level. So the read is about 8 gigabytes per second. I'm sure everybody has already done the math, so I'm going to jump into it immediately. You have 6 of them. 6 by 8.3 is about 50 gigabytes per second. Okay, marketing BS a little bit earlier when I said that it was close to the memory bandwidth of the DDR. DDR is above 100 gigabytes per second. Here I'm talking about 50 gigabytes per second, but still it's much better than anything else that you have. So I'm technical, I'm not going to tell you it's the same, but that's why in that case, when you do read of memory or of system memory, we recommend or we force that you use some DDR DIMMs as cache. And the system does it alone. It's really, really great. In terms of latency, we are getting to something pretty interesting because, so DCPMM is the data center persistent memory module. It's the short for what we are talking about. You can see that the NAND or even the 3D NAND and even the Optane SSD have a good latency. Lower is better, of course. But you can see that when you get to the data center persistent memory module, then you get some latencies that are extremely good. We are here in the range of 100 to 300 nanoseconds. DRAM, theoretically, best is 70. We're more measuring something like 100 to 110 nanoseconds of DRAM latency. So we are within the ballpark. Remember that a 3D NAND is in the range of 70,000. So we are comparing something which is 100, 200, 300 to something which is in this range here, about 70,000, here in the range of 10,000. So you can see the latency is very, very good. And as it gets to a higher bandwidth, the latency increases a little bit, but it's still reasonable. In a dual socket system, you can have 3 terabytes of DDR4, because there are 12 channels, 1 DIMM per channel. With Cascade Lake, we support 256 gigabyte DDR4 DIMMs, so that's 3 terabytes, and 6 terabytes of the persistent memory, total 9 terabytes. What we have measured is that the restart time for some of the solutions that use large databases that need to be pre-loaded or loaded goes down from 20 minutes of load time down to 90 seconds. On top of this, you still need to reboot your system, which will take in the range of minutes. That won't change anything. The system will still have to reboot. So you have to add to these numbers a few minutes, maybe 10 minutes for getting to root, to log in, and then you start reloading your data. A 13x better performance. In terms of cost per database terabyte, then you get to what I was alluding to earlier when I used the word affordable. You're getting to a much better TCO. Again, those prices are the official public prices that we announced yesterday. How does it translate in for some of the applications? In terms of VMs, you can do a lot more VMs. In terms of lower cost per VM, you get a $500 less, so 30% saving. Very, very interesting in terms of capabilities, and that's Hyper-V. As I said, we are not only bringing the non-volatile DIMMs, we are also bringing some new solutions, dual port DCD 4800X. You've been used to the P4800X that will go to larger capacities. And we're also bringing the new ruler type of form factor. That's a ruler of about 30 centimeters with a form factor that Intel came up with, that Intel gave to the community, and that some suppliers have been taking. You can put them in a 1U solution, and you can put 32 next to each other as the new E1L form factor for long. There's also a short one, allows up to 32 terabytes in one of them. You can put 32 of them next to each other in 1U. You have 1 petabyte in 1U. We've seen some customers very interested in that level of density. As I said, all of these solutions based on the 3D crosspoint technology for SSDs as well as non-volatile memory have a lot of benefits. And you can see here that the light blue is the non-volatile memory DIMMs. The dark blue is the data center solid-state drive based on the same technology. In HPC and AI analytics, you can look at the others, but I'm focusing on AI analytics and HPC. You can do a lot more with the persistent memory because in that case, you have much more data available immediately next to your node. And we are seeing that some people are even looking at Scratch and IO nodes with the solid-state drive, but thinking of putting some IO nodes equipped with the DC persistent memory DIMMs so that they get even faster to the data. And I've seen some customers thinking of using the Optane DC persistent memory DIMMs for checkpoint restart. In that case, the hope for each user is that they will write, and never read. Because if they never read, it means that they don't need to do the restart. So that means that we guarantee that if you write a lot to these DIMMs, you still have a certain lifetime for the DIMMs. Because you know that the 3D NAND SSDs, the Optane SSDs, they have a type of wear out. At some point in time, they are not usable or they don't provide the full level of performance because the cells inside wear out. For these, in the non-volatile memory DIMMs, we guarantee a certain number of petabytes written during their total life. It can, and I did the math myself, if you write 500 petabytes over a period of 5 years, then it means that you are writing 3 gigabytes per second, 24/7. So that, that gives you a little bit of the capabilities. If you remember my slide where I showed the table with the read and write performance, 3 gigabytes per second is short of what the max capability is, but that means that you can write nearly at 100% of the time during 5 years, and the system will, or the DIMM itself will not wear out. So, to reassure you that it's not going to wear out immediately. So we talked about the XEON scalable processor, the Optane DC persistent memory, that will work only on the new processor. So don't try it on a Skylake, it won't boot. Sorry. But all this would be useless if we don't have anything in terms of software that supports it and that gives you access to all of the features that we are bringing with this new products. I'm not going to go over this slide, but you've known Intel for some time. You know that when we come up with a new processor, we come up with, or we've come up already some time ago with new instructions that we published openly, with new compilers, libraries, tools, inspectors, advisors, vTune, etc. Nothing changed here. We are bringing them at the same time, available now. Actually, they have been already available for some time, so that people get prepared for taking advantage already of these new processors. But one issue that we have seen at some of our end users is that when they have to choose a solution, they go to their preferred OEM. Let me be a little bit nice. So Lenovo, for example, I mean, or maybe HP, but let's talk about Lenovo, because tomorrow we will have the HPCAC-AI, and that's provided by Lenovo. So Lenovo is a big partner of ours on this. And when the end users talk to Lenovo tell them, oh, okay, we have a hardware solution, and we guarantee that through Intel, your software will be running on it. But then the next question that the end user has is, which processor should I use? How much memory? Which interconnect? Blah, 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 all that kind of stuff. What we have started working on is looking at what customers care for, and what they want in new solutions is technical benefits, and of course they always want better performance, higher security, and they want this to be easy to deploy and use and not have to go through all of the hassles of, okay, I've installed my OS, it's booting, but now which version of the software stacks do I install, or the package? And what they want in terms of business benefits is reduce everything that costs and increase everything that brings value. Typically, they want a higher ROI. So Intel has worked on that, and we've come up with something that is called Intel Select Solutions. There are several tens of them. The idea is that it helps accelerate the deployment of workload-optimized infrastructure through a simplified evaluation, because it eliminates the guesswork that you have to do in terms of which hardware do I need to put under that. And we have validated that the hardware and software solution that we are suggesting here work well together. It's easy to deploy because it's sure that it will work all together, and it is optimized as per some benchmark that we have done to guarantee that you get a high level of performance. And usually what we come up with in terms of benchmark is okay, SpecInt, SpecFP, LinPack, LAMMPS, WRF, name them, stuff like that. But you don't necessarily want to run WRF or LAMMPS. Maybe you do, but maybe you want GROMACS, and in that case, maybe we don't have the benchmark, and we can't tell you whether it's better to have a 6248, an 8260, or an 8280, or a 9282. So this is coming to help for all of that. As I said, there are already about 15, 20 solutions that are available, a lot more in the pipeline. On the HPC side, there is a Intel Select solution for simulation and modeling, one for SDVs, software-defined visualization, called here professional visualization. There's one for genomics analytics, and there's one coming soon on HPC-AI converged. All this is important for people who just need a solution. They don't necessarily want a black box, but they want something that will work, and they don't need to be putting their hands in it each and every day. These Intel Select solutions are done with some ISVs, OSVs, with some OEMs, I named Lenovo a second ago, and with scale partners that all work so that they make it available to their end users. So you can get it from your preferred OEM, but you can also get it from, let's say, smaller companies that are providing solutions and that can now then rely on something which has been proven, tested, and benchmarked. How am I doing on time? Okay, then I will probably need another 2 minutes. So what I've shown you today is that Intel is increasing the portfolio of solutions and ingredients that we have for the data center types of workloads, with solutions to move the data, solutions to store the data, and many solutions to process the data, with more and more solutions being available now and coming in the future. Some have been made public already in terms of acceleration. We have accelerated inside the processor some of the AI workloads. There are some accelerators that will need to be outside of the processor, like the FPGA or some others to come, and we are moving into that direction. As a summary, the new second generation Intel Xeon Scalable processor, codenamed Cascade Lake, with all of the other ingredients that have been announced last night, are bringing a new level of performance, new levels of features, especially in terms of computing, in terms of AI, especially for inference, and in terms of this new memory hierarchy that is bringing, through non-volatile memory DIMMs, data much closer to where it needs to be computed, and that's bringing a new level of possibilities, a new world of possibilities in terms of how to localize the data when you have to put together a solution for your problems, for the end users to think, okay, it used to be in the warm space, maybe some of it I can put it in the hotter area, maybe not in the DDR DIMM yet, but closer to it because I have a large space. By the way, as I said, this space can be used as system memory fully transparently. It can be used to store file systems, but it can also be used to write directly from your application through special mallocs, so that you can also write your own data and retrieve it later on this non-volatile memory DIMMs. All this is bringing a new set of features that I'm sure you will be taking advantage of. And if you need to know more about it, I'm open to questions, or we can talk during lunchtime. Thank you.